Hi guys. So I told you guys you wouldn't have to do anything extra on Monday, or did I? I don't know, but I changed my mind. No. So I think some of you might be done with Friday's activity. If you are, you can read over this and start it if you like. Otherwise, we are going to do this on Tuesday, but I think it's kind of an interesting activity. So the phenomena that we're going to study is spacecraft require forces to change their motion. And we're going to be focusing on inertia, like things want to keep on doing what they're already doing. And that's what we're focusing on. So think and wonder, in what ways does a spacecraft obey Newton's first law of motion, which is inertia? And then also, based on what you've already learned about inertia, give examples of how a spacecraft changes its motion. Okay, so how does it overcome its inertia? Okay. So you're going to read the background information, and you're going to read each of these articles. It's one article, and it has 4 different goals talking about why basically NASA decided to send another rover up to Mars. So one is to determine whether life ever existed. Goal 2 is to characterize the climate of Mars. So we're looking at the climate. Goal 3 is characterizing the geology of Mars. We're looking at rocks and rock layers and looking for evidence for life. Goal 4 was to prepare for human exploration. So in goal 1, what you're going to do is you're going to look for a sentence that explains how other rovers' missions were different from this one. So you go back up to goal 1, read it. When you get down here, it says, here it is, earlier rovers first focused on and confirmed that Mars once had habitable conditions. So you highlight that, copy it, and then bring it down here and paste it into this box. And you're going to do the same thing for number 3, number 4, and number 5, looking at goals 2, 3, and 4. Then for part 2, we're going to talk about inertia, motion, and forces. So going back to that activity that we did, I think we did it like on Wednesday last week. You want to explain, Newton's first law explains that objects keep on doing what they're doing until an unbalanced force acts on them. So in your own words, what does inertia mean? Number 7, when a rocket is sitting on the launch pad, what unbalanced force must work against the rocket's inertia in order to launch it? And then once the rocket's far enough away from the Earth's gravitational pull, the capsule at the top that carries the rover is separated from the rocket. At that point, it was traveling about 24,600 miles per hour. NASA allowed the spacecraft to travel for 15 days before using any of its onboard rockets. So based on Newton's first law, what do you think the speed of the spacecraft for those 15 days would be? Remember, there is no friction in space. So is it slowing down, speeding up, or staying the same? Okay, number 9. Once NASA made several adjustments to its path, after a 7-month journey, it was ready on February 18th to enter the atmosphere of Mars. Why did the spacecraft start to slow down once it entered the atmosphere? And here's a hint. No rockets were actually needed for this change of motion. And then number 10, describe the spacecraft's final change of motion. Here it is, its final change of motion that occurred around 1 p.m. on February 18th, 2021. And then for those of you who are curious, there's some additional links below. You want to read about the goals a little bit more in depth, there they are. So thank you very much, and I will see you on Tuesday. And I need you to make sure you have all missing work submitted to me by Tuesday because my grades are due on Wednesday. Thank you, and I will see you on Tuesday. Bye.